All right. A very warm greetings to each one of you. And today we are gonna learn about a very interesting and one of my most favorite concept in the advanced cryptography, that is fully homomorphic encryption, or in short term, we it is often known by FHE. So what exactly is FHE? FHE is actually an advanced cryptography method, which is a very special type of encryption. Like in cryptography, whenever we talk about cryptography, there are two key concepts involved every time. So the first concept that is involved every time is encryption, and the other concept is decryption. And between encryption and decryption of data, there's always functioning or a processing of the data. So like if my data wants to be sent from me to other person, then needs to be a process involved in it. So these three are always key features in cryptography. But what exactly is FHE? So basically in FHE, you are processing a data without ever needing it to be decrypted. So how it is different from a traditional point of view in cryptography. In traditional cryptography, whenever I want to send my data from one place to another, it first it gets encrypted. Like when I'm sending my data from one phone to another phone, first it gets encrypted, then it goes into a transportation. Once it is there into transportation, it reaches an authenticated decryption authority where the data is decrypted and the process that is want to be made on the data happens there. And after that, they again encrypt the data and then it is sent back to the source where it is going to. So basically, in this case, when my data is going from source A to source B, there's always a decryption happening in between, and this leads to a very high risk of data loss and data leaks. And we can also see it from example and from very time to time. If we see into the market that the big MNCs, uh, they are always said and they're always found guilty of sharing the encrypted data and privacy breaches. To solve this method, we came across a very interesting term, which was fully homomorphic encryption. So a bunch of cryptographers, they sat together and had an idea that what if the process that we are making on the data, what if how we can uh, if we are able to achieve a cryptography method which does not even require the data to be encrypted, which requires the like in this way, uh, the process would be held onto the encrypted data only. That's where the FHE was born. So basically, cryptography is just not about securing information. It's about building trust between ever increasingly interconnected world. And FHE is like in the coming few 8 to 10 years, FHE is going to be the base of that, as the more data the world is having right now and the more data the world is consuming, the more is ever going to be the risk of privacy breaches and the data leaks. And in this way, the FHE, what it does is that it is never, since it is never decrypting your data, it will never know that what is exactly inside your message or what is exactly inside that package material that you have packed, and the process is happening very smooth. And also on the on the top of it, when the process is taking place, the verification or the process that goes inside the function is also publicly available. So basically, people can also verify the functions, that which kind of function is happening there. So in this way, the transparency is also maintained. But in on the other hand, there is also no risk of data leaks. Now let's go and try to understand the key terminologies used by FHE. So the first key terminology that is used by FHE is called a decryption key. So basically, a decryption key is just like as it is written here. It acts as a master key. So in this, that there's a master key of the crypto system from all the other uh, from which all the other keys can be derived. You can say it as a public key and basically or a private key. Sorry. So basically, a decryption key is always there into the hands of a master, and with this one, like with this key, you can derive multiple parts of the keys. Now comes the another part, which is the encryption key. So in a public key mode, when the party that provides the initial ciphertext is not a decryption key, it is then called as an encryption key. So this encryption key is used to lock the data before it is shared or stored. And the last part of the FHE key terminologies is an evaluation key. So basically, evaluation key is also like it's also publicly available key which can be shared to everyone, but it allows computation on encrypted data without revealing it. So basically, this is the function that I was talking about. That with the help of the evaluation key, you can process the data on the encrypted data itself, and whatever you're doing can be also visibly like can be publicly be visible. So in this manner, the FHE has the balance of how the things are working and how the encryption and decryption take place. And in the FHE, there is actually never anything that is being decrypted. It makes sure that most of the time, whatever is happening on the data should remain encrypted. And that is what the core concept around FHE is. So like if you go out there and like if you want to explain to your fellow developers or like fellow colleagues that what exactly is an FHE. So in simple terms, you can just say that FHE means that to process on data without ever needing it to be decrypted, without ever needing it to be decrypted. Now, why was it was really invented? So basically, there is a kind of an authenticated encryption. So authenticated encryption is a general encryption. So basically, let's take an example of like the like let's say like the current US votes were held on to the FHE. So in this way, and I want to make sure that my votes are correctly counted and are correctly encrypted. So what I'll do is that my vote is gonna take like I'll do an e-voting, and my ballot of votes are gonna go to an authenticated trusted party. And when I'm sending my vote, I want it to be encrypted, right? So that no one can see it. So in this way, my votes are going actually to an authenticated encryption party, and there the authenticated encryption party, which we all mutually trust, is going to decrypt the data. But there's always a risk of a nefarious user in that. So basically, if there's a nefarious user in that authenticated encryption party part, then in this case, there will be like in this case, it can give some votes to like say Donald Trump or can give some votes to Kamala Harris, and there can be a misuse of the information there. But what if we like instead of doing that, we included an FHE based e-voting part where the counting of the vote would be done onto the encrypted votes only. In this case, we know that the function that it is going is towards is never gonna like decrypt our data. So in this way, we'll be entirely trusted on it, and we'll have uh, a, a faith that the result that is going to come, the output of this hypertext that is going to come out from that engine is always going to be well calculated and would be in most cases attack free. So, so now that you have understood what exactly is like FHE, now let's try to understand some of the traditional methods of FHE which were used. So the first method that was introduced in FHE was is called as outsourcing mode. So outsourcing mode is solidly one of the first ever methods that was ever introduced onto the FHE, and this involves a, s- a simple circuit where let's say there is a party called Alice, and Alice wants to do some computation on the data, but Alice does not have that enough computation power. So Alice is gonna send that data to a third party, and that third party is gonna do the computation on the behalf of Alice. And let's say the third party is Bob, and Bob is gonna do computation on the part of Alice, and then Bob is gonna send the data back to Alice. Now, I know that Bob has made a significant reputation into the market, and that is why it is called as like as a trusted third party. And and certified number of Alice's and let's say Caroline and everyone are sending the data to Bob. But What if that Bob is going to hire a nefarious or a malicious attacker or a user who starts compromising the data, and the output of the computation power that it is going to give is going to be a different power. So in this case, what we the first FHE that was ever introduced was an outsourcing mode, in which this computation power would perform a function which will be publicly visible, but it will perform a verification model onto the encrypted data only. It will never include a decrypted data. So in this case, there will be always a one decryption key which will be at the Alice's end, and an encryption key will be used to log the data, and it will be used to send it to the Bob. Now Bob is gonna carry out the function onto the encrypted data, and using that encrypted data it's going to send that same encrypted text back again to Alice. Now Alice has logged the encrypted text with her encrypt key, so it's going to unlock the same ciphertext, or not the same ciphertext but the result of that ciphertext of the processed data, and it's going to get that data towards her. So in this case, what is happening is that Alice is never revealing or never sharing its decryption key to anyone, and the data is never being used. So let's say Alice wants to have, like Alice has a table of her earnings, and she wants to know what exactly her what exactly is the average of her all monthly incomes. But she is hesitant to share her monthly incomes, and she does not really want the third party, or Bob in this case, to know what exactly she was earning every month. So in this case, what she can do is that she is going to send the table of her list of her earnings into an encrypted form, and then she's going to send that list to Bob. Now Bob in this case will perform a publicly verifiable average function onto the data, and once it is performing onto a data, it's going to send back that same data again to the Alice. And in this case, Bob never knew that what Alice was earning, or what Alice had on her monthly income, and and in this way, it is also uh, gaining more trust of Alice, as well as preserving that if any attack happens onto the Bob's ecosystem, then in this case, Bob is like the information of Alice's is not exactly leaking. So in this case, there is always a circle of trust, or we can say in terms of an aura of trust, which is revolving around the whole part, and it is going to ensure that every transaction that is happening is most secure, and it is cryptography correct to the best part. So that is something about the outsourcing mode. So from the step by step, if we consider, so the first step is going to be encrypt the data, and then after encrypting the data, it's going to send it to the server. After sending it to the server, it's going to process the encrypted data. Once the encrypted data is already processed, it's going to return that encrypted data result, and in the end, it's going to decrypt the result. So it's going to work in a linear fashion, and every process is going to be done only once the previous process is completed. And in this way, if anything happens in the middle, then the process can easily stop there. And and if an attack happens in any of the steps in between, it's going to happen on an encrypted data. And if an attack is happening on an encrypted data, it is just similarly like if an attack is happening on a public information, and it's going to have a no relevance on it. So this was the first one of the first outsourcing mode, which was uh, introduced by an FHE. So now let's understand what exactly were the pros and cons of it. So the pros was obviously the data privacy, that it ensured that the data would always remain encrypted during the process, and the no external servers or computation powers could always access it, so that if an attack could happen onto the computer onto those external servers, there was also it also minimized the risk of that as well. And then came the efficiency part. So basically, in this case, Alice was not really able to compute the process on her own. So she offloaded her task to another powerful external server which Bob had, and which increased the efficiency of all the tasks that Alice already was having. And then it is also good for costs savings, because using a third party power can reduce the need for in-house infrastructure, so that Alice, if Alice wanted to find out the average of her incomes only once, she would not really need to include the whole infrastructure and do FHE on her own. She could just simply give it to Bob, and Bob in this case is going to be highly trusted, since Bob is using FHE on its core, and it is gonna reduce the cost of actually in like implementing infrastructure in house. And the last could be the scalability, that cloud services allow for easy scaling, accommodating large or complex data set. And as we know already, that cloud can be very useful for scalable, and for big organization for this case, it is also very useful. Now comes in the part of what exactly were the outsourcing cons. So the outsourcing cons was trusting third party, and this is a con. But yes, if the trusted third party is relatively have a new engine, then the trust can be a little low. But as soon as the time is gonna pass, the trust will be eventually increased, since the FHE that it is going to maintain is gonna have a publicly verifiable record. This here can be performance over it. So like if Alice wants to send it to a third party Bob, which is not using FHE to its core, that process could really process the data that Alice has sent fast, since the since in that case, let's say David is gonna process the data on the on the decrypted part. So David can oh, okay, I'm sorry. So David can process it more faster as compared with Alice, and in this case, but yeah, it is a performance overhead, but it is also going for a privacy breach. Uh, so to always maintain a trade-off, if you want your data to be not leaked, then you can always go with the privacy, and if you want your data to be completed faster, then you can just go with the engines which are not exactly using an FHE. And then is the data transfer time. Since the data that is transferred from Alice to Bob is encrypted data, so the transfer time is always going to be high, and and the complexity that since the functions that are performing onto the data are highly are like encrypted, so the complexity is always going to be high. Now comes the another part of FHE, which was two-party computation. So like if you remember into our earlier part, we explained that into the first computation power, there was only one party which was providing the data to it, and not any other party. So in this two-party computation, it is actually a joint, let's say a joint operation, where like earlier only Alice was providing her data to the computation, but in this case, Alice and Bob, they are gonna jointly provide the data for the computation, and after that the computation is gonna happen, they're gonna return back the result, and then a comparison will happen. So in this case, this was like the outsourcing mode was made for was one of the initial parts, and the two-party competition was included as one of the advancements to the FHE. So let's try to to understand it let's try to understand this with an example as well first. So there is a classic case of a millionaire problem. So what does the millionaire problem mean is that there are two millionaires who are very high in their egos, and they always wants to compare that who is richer than whom, but they don't really want to share their incomes with anyone, and the competition is always between the two of them. So what they're gonna do is that they're gonna involve themselves into a homomorphic encryption e- eco, and there they're gonna compute their data, and the result of that is gonna say that who is actually more richer than the other. So basically, let's say Alice is the millionaire A, and Bob is the millionaire B. So what Alice is gonna do is that Alice is gonna send her net worth to Bob. It will be encrypted, and then Bob is also gonna send his network to a computation power in between, and in that computation power it's gonna compare the network A with network B, and the result of that network A and network B is gonna be sent to both Alice and Bob. So in this case, only the result is going to be sent out to Alice A and to Alice or Bob, that if Alice is greater or Bob is greater, and not really the amount. Like if Alice is worth 100 million and if Bob is worth 200 million, then the result will be that Bob is and that the amount Bob has is greater than Alice, but it won't really tell how much or by how much. So in this case, like it is doing all the, you can say, the God's work in this one, as they want their data to be computed. Yes, they wanted to be compared. Yes, but they didn't really wanted to share the information on what kind of data was really computed or decrypted. So this is a classic case of it. So there are actually three parts included in this, which is the private data contribution. So and like uh, or both Alice and Bob provided their private data contribution to the function. Then there is publicly verification happening, or or in most of the cases, since this is competition between just two parties, so in this case the verification can also be non-public, and it can also happen in a private form. And the third is that honest but curious model, which is the model should be like the model which both of the parties are going to select will be agreed upon, and they know that the on like that the model is going to be honest, but it is also going to be curious that it can like if it is provided with more kind of data, it can also reveal more part. So in this way, uh, the more data you can provide, the more better the result or the more clear result you are going to get. So the pros and cons of this is that the pros is privacy protection, that the both parties data remain private as they only see the final result. But the con is that the complexity is always going to be increased. So like in case of FHE, since we're really at we are really scratching this surface right now. So a con of having increased complexity, having higher computation costs, and having a communication overhead is always going to be there in any kind of FHE methods. And the pros are always going to be almost same, that it is going to have a secure collaboration and data confidentiality and privacy protection. So so you can say that this pro and this con is actually generalized for all the FHEs, and until the more work is to be done, we can like slowly and steadily the complexity of these tasks can be reduced for sure. Now comes the part that how does exactly homomorphic encryption ensure that the functions computed are legitimate? So since like you might be having the question that if I'm doing the process is happening onto the encrypted data, then how exactly are the function how exactly the result that I'm having is legitimate or not? So in this case, the simple concept of is that to introduce redundancy. So basically, let's say, and let's go back to the first example of outsourcing mode. So when we saw into the outsourcing mode, we saw that in outsourcing mode there was a part that the I was getting the result of my encrypted data, and I was Alice, and Alice wanted to know the computation of her average incomes, and she didn't know that. So the encrypted, so the data what so the output data what she was getting, she assumed it as to be the right result. So in this case, she can also go, and she can also let's say in the list of the table, she can uh, rearrange that list but having the same data, and she can again send that list to the same FHE compiler, or she can also choose multiple FHE compiler which are doing the same task, and then she can compare the result of all those, and then you could understand that whether the result was right or not. So the more the redundancy is going to be there, the more ensurety is going to be there that the process output is legitimate or not. But always the more the redundancy is going to be there, the more time is going to always take. So there's a trade-off in between this as well. the trade-off between the processing time and the data accuracy. But as soon like the sooner the FHE engines are going to be developed and progress, the efficiency is going to be increased and the accuracy is going to be increased both as well. Now comes the part that how does FHE ensure that the funnel recipient decrypts only the funnel result and not the intermediate variables. So now let's consider the method where the earliest method that I explained about the e-voting. Okay, before e-voting, let's consider another linear method, and let's again consider the Alice's method. So when Alice wanted to, so now in this case, Alice wants to have a computation on her average incomes, but she does not want the result to herself. She wants that result to be sent out to Bob. So now Alice has, so now Bob is not exactly participating in it. So it is not a two-party competition. It is just an outsourcing mode, and Alice is handing her data to Bob. Oh no, sorry. Alice is uh, Alice is handing her data to Bob, and Bob is doing computation, and Bob is then gonna send the data to David. So, and Bob is gonna do the computation, and David wants to know the average of the Alice's incomes. So, and let's say Bob wants to grant a loan to Alice, but Alice does not really want to tell that whether she is eligible for a loan or not. So, this is a classic case of financial problems. So, what Alice is gonna do is that Alice is gonna send her data to Bob. Bob is going to perform the process on it, and it's going to send the data to David. So now it's going to make sure that only David can only access that public that output, and David cannot really access that input. So as David is only going to have a decryption key, which can only access that particular output. So in this case, it's made sure that it can only access the funnel part and not really anything in the between. And now let's consider a part of e-voting. So basically, in e-voting, what we can do is that we can introduce a multi-party computation part there. So let's say that all of us wants to vote, but a decrypt key is not going to be owned by only one person. A decrypt key will be owned by a multi-party peoples. So now, for decrypting my vote, I need approval from all of the people who is going to have that key, and only when all of them is going to have a consensus of decrypting my proposal, then only I can go forward with it. So in this way, it is made sure that only the output or only the final part is received by the is decrypted by the user and not really anything in between. Now we come to the end of the discussion for the today's class, which is the building block of homomorphic encryption. So the building block of homomorphic encryption, which we have explained throughout, is that first it needs a public key encryption, then it is a ciphertext manipulation. So public key encryption is a data which is encrypted with the public key and can be only decrypted by a private key holder, and a ciphertext manipulation, which allows operation on encrypted data, and then evaluation key, which enables authorized computation on encrypted data without any third-party decryption, and then the last is secure multi-party computation, which allows multiple parties to compute jointly on encrypted data without exposing their private inputs. So with this, we come to an end of our discussion on fully homomorphic encryption, and I would like to end it with a short note that why it is exactly needed is that like in the current market, when we say that we should be responsible for our own private keys and we should be responsible for our data lakes, it should not really be the case. It should be, and that is where FHE is introduced, and FHE is going to make sure that it's gonna take that burden off from the people's head, the people that does not really want to include themselves to anything, but they just really want to involve in a secure party, and they just want the data to be not leaked. So with this case, we can really cater to a million and billions of users around there, and we can make sure that their data always remains private, and it is not happening to the and it is not really going to any public feeds, and it has a very high use in all the actors, like from the financial institutes, from healthcare, and to all these actors out there. And with this one, I thank you all for joining me today in this webinar.